cubics in the form y equals a x minus b all cubed plus c. So this is the form that we're looking at. It's very similar to the quadratic form y equals a x minus b all squared plus c, except that the key point here is the horizontal point of inflection rather than the turning point. The point of inflection will be at BC. Notice how the sign on the B is changed but the C stays the same. The sign of A will determine the direction of the graph. If A is a positive number, then as x tends to infinity, y tends to infinity, and as x tends to negative infinity, y tends to negative infinity. That means it's shaped like this. So as x becomes increasingly negative, the curve disappears off the bottom, which is what this means. And as x becomes increasingly positive, the curve goes off the top of the graph, which is what this means just here. If a is a negative number, then as x tends to infinity, y tends to negative infinity, and as x tends to negative infinity, y tends to infinity. So in other words, the graph is shaped like this. As x becomes negative, y becomes very large and positive, and as x becomes large and positive, then y will become large and negative. The value of a can be determined in the same way as with quadratics, going one unit right from the point of inflection and seeing how far we go up or down to meet the graph again. So if we take an example here, first of all we can see the point of inflection is at 1, 5. Then if we go one unit to the right from there, we have to go 3 down again in order to meet the curve. And that tells me that a is negative 3. Now with the horizontal point of inflection being at 1, 5, I can now say that this graph is the graph of y is negative 3 because a is negative 3, x minus 1 because we can see the x-coordinate of the horizontal point of inflection is 1, add 5 because the y-coordinate of the HPOI is at 5.